Like the people that are actually performing the work. Those are like they are involved in operational sphere, and they're concerned about this week's work getting done, and they might need some reports, and they're like at the lower layer of this pyramid. Then at a slightly higher level, you have the operational managers, and they are not so much interested in the separate orders being ready or whatever. They just want to know that they got their figure for that month, right? So they need some aggregation over all the individual cases handled in the operational systems, and that's the second layer you see there. And on top of that, you get analysis, and analysis is, you start to talk about analysis when you're not so much concerned with the really I need to get my work done type of questions, but when you're busy with thinking ahead and trying to figure out what figures you're going to make this year, and when you're trying to think ahead of what the other companies are doing, and that's when you're doing that, when you're looking at data from outside your company and you try to look at trends and things that are happening outside your direct sphere of influence, and you want to use that in your the way you run your business, then you're talking about strategy, and that's beyond the so that's a whole spectrum of increasingly more abstract and more higher level reporting of your business. And for all these different flavors and aggregation levels, you have the different parts of your company, and those are normally called data marts. So you have the sales department, marketing department, inventory department, and all these people have increasingly higher levels of management and other needs for reporting. So this is what this pyramid is showing. Okay, so one of the differences between the data warehouse and your the typical operational database schema is that a data warehouse is organized in the so-called star schema, and the difference is basically that in an operational system, a database schema is designed with a focus on maintainability of data. You want to prevent that data is stored in the same data is stored in multiple places, because if somebody is going to change the data, you're going to have to change it in two places, which of course doesn't always happen, which is a source of error. So that's why in an operational system you're focused on maintainability of data, and the things you have to think about is elimination of redundancy, making sure that everything is normalized. And in the data warehouse, this is all very different, because the data warehouse is used for reporting. It's not used, typically you don't update a data warehouse other than to load the new events, the new business data in there. But you're not going to go back and change things. You're just going to keep a record of a snapshot of your business at a point in time, and you're just going to accumulate that over time. And also because the data warehouse is mostly a read-only thing. I mean, the consumers of the data warehouse are just reading from it. There really is no need to have all this normalization, foreign keys, other kinds of constraints, because you take care of that while you load the data warehouse. When you load the data warehouse, you're going to make sure that everything adds up. You're going to make sure that every reference is resolved, or that the references that are not resolved actually get tagged in a way that it's easy to see that they're not resolved, so that it's completely clear afterwards what kind of data you're looking at. And then afterwards you usually don't touch it anymore. So for that reason, the data, because of these completely different requirements, it behooves you to choose a completely different type of schema, which is star schema. And the star schema, the essence of star schema is that you have basically just two types of tables. You have fact tables and dimension tables. And the way this translates to in your business is that when you look at your business processes, there's always some central thing happening. For example, when you have a store, you sell some product, then the fact that you sold this particular product to this particular person at this particular time in this particular store, and that this person paid this particular amount, this amount is a fact. And you can, accumulate all those facts for all your stores, for all your, customers, and that's what you put in the fact table. And then you have these dimensions which you use to, to basically to cut up all these facts and span. You use the dimensions to span up your space of facts. And this is a little bit abstract, but it becomes a little bit clearer when you look at this little crosstab on the bottom of this slide, where you see a typical crosstab report, and you see the sales for a particular type of product. In this case, the product is electronic devices. So we have laptops and monitors and PCs, and we are looking at the sales over time. So we see the sales for 2001 and 2002 and 2003, and the actual fact here is the sum of the amount of money made on this particular purchase, or maybe it's the count, it's the number of items sold. I don't really know, but the thing is that the fact are the numbers, and usually you don't look at individual numbers, you look at an aggregation of numbers, aggregated over time, aggregated over store, aggregated over product category. So in this case we see aggregation over product category, laptop, and time. And the number you see here, the 2,800 something, is actually the sum or the count of items that fall in those two categories. And a typical business user would see like, hey, that's interesting, we sold so many more laptops in 2002, and they want to know why they sold so many more laptops as compared to 2001 and 2003, and they would be tempted to what they call drill down and cut the year 2002 even further into quarters and try to identify which part of this data is actually responsible for this different result. And then they get all kinds of wild ideas and want to start new marketing campaigns because they see this phenomena happening in their data. And this is typically a BI thing. So here we see another rendering of this star schema design. Again, we see the fact table in the middle, and so that's basically why it's called a fact table, because we have a central fact, and around it we have kind of a star of dimensions spanning up this fact space. We have a concrete example here of the Sakila sample database, which comes with the MySQL database, and this is a DVD rental store. And what I did is I created a little diagram of the thing. And what you can see is that basically this schema is used for the operational DVD rental store data entry system. And we see that it's basically object-oriented. Object-oriented not in the sense of object-oriented languages, but you see that the tables are centered about the particular things that happen in this video store. So in the top we have the object film, and the film and everything that belongs to film. So the number of actors, the categories, that kind of stuff is all film object. And then below that we see the store object, and the stores is about the stores themselves, but also about the staff members working in the store, and also about the inventory of films that is in stock of this particular store. And then we see on the right side we see the addresses. So this is very typical for an operational system. We have one table or one piece of the database that stores all addresses, and every time you need an address, a store address, but also a customer address, it all is drawn from the same tables, and that's on the right side. And way below we see the customer, and the customer is an object in itself too, and in this case it's the customer data, so it's his name, also his address, because it's referenced to the address table. And we see their payments and customers. And you can see that there's a lot of relationships going on between all these tables in order to make sure that when some data is needed in some object, it's referenced rather than duplicated. So this is typical operational design. Well, if you want to do reporting on this thing, and you want to figure out the amount of rentals or the amount of payments, then you're going to have a hard time, because you're going to have to somehow join all these tables together and make sure that all the aspects you want to look at when you're thinking about rentals or sales. You're going to have to, well, query this every time again. And this is why you create this data warehouse. A typical star schema rendering of this same schema to report on the rentals would look like this. So this is not an object-oriented schema anymore. This is an aspect-oriented schema, because we have in the middle the fact, the rentals, and we have a dimension table or dimension tables for particular aspects. And the aspects, the easiest way to look at it is to ask yourself, if I have rental facts going on, to ask yourself who is renting stuff, or who is renting it for you. The second thing to ask yourself is what is being rented. So in this case it's films. And then you can ask yourself where is this stuff rented? And it's rented in a particular store. So that's on the bottom, you see. And the final and pretty important aspect is time. When was stuff rented? And you see that the data from this operational system is basically, first we start with identifying the tables that contain potential facts. And in this case it's the rental table and the payment table in our operational systems. They contain, in the case of rentals, it's not a real fact, but in the case of payment you have the amount. So that's a fact. That's something that's a metric you can actually add up and count. And the next thing is, well, you identify your dimensions. So in this case we ask the who, what, where, when questions. And for Sequila we come up with customer and staff for the who question. We come up with film for the what question. We come up with store for the where question. And we come up with rentals, date and time for the when question. And the thing is that these dimensions are just a particular aspect. And the thing is, this aspect can be divided in a number of increasingly finer grained categories. For example, time. Time is a pretty abstract concept, but we can divide it in year, quarter, month, all the way down to day. And for store, for example, store is, well, it's a pretty concrete dimension, but when we're looking for reporting, we're probably gonna not ask about stores, but we're gonna ask all stores in all of the world, all stores in Northern America, all stores in a particular state, and so on and so forth. So these dimensions are divided in what they call hierarchies, and these hierarchies contains a number of categories which represent a grouping of the facts in an increasingly lower level. And this is actually what allows the reporting tools afterwards to drill down and slice a smaller piece of the facts out. So quick mapping. We see the address bit in our normalized schema is in the middle here. So we have different tables for country, city, and address in the operational system. But in the fact, in the star schema, we have these addresses are duplicated into the store dimension and duplicated into the customer dimension. And this allows us to break down customers and stores from country to city, to district, to individual store or individual address. Same thing or similar thing for the films. In the films we have film have languages. Those are duplicated into the film dimension. But we also have a multiple of categories for which a film can fit into. And in order to be able to break down on category later on, we need to kind of, well, when we have one film, we can have multiple categories. And we need to get rid of that, because if we would have multiple films for every category, we would be counting films more than one time in our fact table. So we have to kind of take these multiple of categories and kind of flatten them out and turn them around, and they become columns in our dimension table. So we kind of pivot the multiple categories into columns. And we do the same thing for the special features. So this is like the introduction about the data warehousing, about how you set up this data warehouse. And now it's time for Matt to show you how you can actually use use this tool to do it. Okay. Okay.
You're doing fine.
Okay. So I like to start top down. We have this star schema over here, and I showed you the operational schema, and because if we design this data warehouse, that's all fine and dandy, but we have to have something which actually makes sure it gets loaded, right? That we actually get the data from our operational systems and put it into our data warehouse. And in some cases, this can be a very easy process, but unfortunately, in many cases, it's not easy. In a lot of cases, you have different source systems where you have to get data from, which are actually merged into a data warehouse. And it rapidly becomes very hard and complex to do all these things manually. So what you use is a specialized tool which is designed for this type of data juggling, right? And this data juggling, this loading is called ETL. So it's ETL, E for extraction, T for transformation, and L for loading. So extraction is pulling the data out of the sources. Transformation is, well, for example, we just saw how we had to map, the multiple of categories to number of columns in our dimension. That's transformation, because the data in the source format is not sufficient for our destination format, so we have to transform it. So that's the T in ETL. And then finally we have the loading, and the loading is making sure the data is actually put in the data warehouse itself. ETL. Well, Kettle is actually the former name of what is now known as Pentaho Data Integration, and Pentaho Data Integration is the ETL tool of the Pentaho suite. And we're just going to do a little demo of this tool. So what you see here is the entire transformation, and this is called a job. This is something you can run, just like you can run a program. In this case, this is a program to actually load our data warehouse. So we have a start, and first what we do is we upload the store dimension. We find every new store in our operational database and put it into our data warehouse. And we do the same for staff, and the same for customer, and the same for film, and the same for, finally, the rental facts. Of course, this tool doesn't magically know how to do this. These things are broken down into even smaller parts called transformations. So a job is a collection of steps, which are usually transformations and some flow control. And I think the concept of a job here is that it's execution based. It's something you do. You load the stores. That's it. You load the staff dimension. You load the customer dimension. And the transformations are actually about data. They have to do about flows of data and where it's routed, where it's transformed, and where it's put into. So to load the store dimension, we have a few steps. Well, it's unsurprisingly, it's always the same, almost always the same. You have some input, you have something output, and you have something in between. That's simple, but that's the way it works. First, what we do here is this is our start of our transformation, and we pull out the data from our operational system. So in this case, it's a simple select operation. You have to know a little bit of SQL, but this is, I guess, one of the characteristics of these ETL tools is that they're designed in a way that you need only minimal amount of programming knowledge. So, for example, this is a bit of SQL that's typed in there, but it's not actually. We didn't actually type it. What we did is we did a little wizard, and we just went into our source system, and we did a little bit of browsing for our data, and we just clicked. We just told the tool to use this table, and it actually generated the SQL for us to actually pull out our store data. So store data from the operational system, nicely normalized, all kinds of IDs to staff and to address, and of course we have to somehow make this ETL tool pull in all the reference data in order to actually fill out our dimension table. So the data travels from this step to the next step, and it's called fetch store address. And what this here is, this is actually a sub-transformation. So when I create a transformation, I can actually reuse it in other transformations. So for loading the Sequila database, I have customer addresses and I have store addresses. And in both cases, I need to do the same operation, namely fetch the address and make sure it's all nicely laid out in the dimension table. So that's why I created a separate transformation, fetch address, which I use in multiple transformations to actually reuse the work I did to look up addresses. I can show you the fetch address transformation later on if you like. Finally, we have in the store, we have two things. We have addresses and the store manager. And to actually find the store manager data, we actually do a lookup in our operational database. And basically, this is kind of a join. If you have a pure SQL solution, you would actually join this stuff. But in this ETL tool, we want to have the tool do the work for us and not bother too much ourselves about SQL. So what we do is we just declare that the flow data, which we gathered in our input step, is actually looked up against the data in the staff table, and we pull out all these fields over here, which will actually become part of our stream afterwards. So we can show it like this. Yeah, we can. I'll do that. So here we just have these few fields, and then afterwards, after we have this step over here, we suddenly get a lot more fields out of there, and after this step even more, we get a lot more. So gradually we just pull out more data and just adorn our stream with more and more data out of our operational system. And finally we store it into our customer dimension table. And we can actually take a look at the data. So when we start here, so this is basically our operational source data. Not very interesting, just 2 rows of data. And then after this step over here, we actually, oops, okay, yeah, okay. So we still have the 2 same rows of data, but by now we have gathered a lot more, address fields, and a lot more data. And so finally we store it in our customer dimension, and we can actually run this thing in its entirety. So we just launch it, and then we see here the steps, and we see it's already done. It's so fast we can't actually follow. I'll run the other transformations some later on, so we can actually look at stuff happening. Okay, so store dimension, staff dimension is kind of the same thing. Customer dimension is also kind of the same thing. It's all very similar to what we just saw. Film dimension is a little bit more interesting because we had to do this weird transformation of categories and special features, and we had to roll them out into our dimension table. So if we take a look at that, it may look a little bit scary, but it's not that scary if you're creating it. First thing, yeah, sorry? Yeah. Okay. So first we start with the source data again, and if we look at that, we get some typical film data. We get film ID, title, description, and some other fields. And the things I wanna like you to focus on is special features. You see here this in our operational system, the film table has a special features column in which a list of features is maintained, which tells something about special features for this DVD. So you have some DVDs with deleted scenes or trailers or whatever. Well, in our data warehouse we can't use this type of data because we can't select on it. What we would like to have is to create a separate column for every type of feature and have a yes/no flag in there, so that people can easily select all the movies with deleted scenes or all the movies with trailers. And in order to achieve that in Kettle, we need to do a few things. Here is where we actually take the list of special features and normalize it. We actually cut up the list and make separate rows out of it. So if we look in this step and do the preview, we can actually see that for the Academy Dinosaur movie, that used to be one row in our input data, but now it's suddenly 2 rows, and it's suddenly 2 rows because the special features, deleted scenes and behind the scenes, have actually been cut up into deleted scenes, 1 row for the deleted scenes, and 1 row for the behind the scenes special feature. So it's a normalization. We're cutting up the list and making separate rows out of it. And in the next step, because we want to have a yes/no flag in our dimension table for these special features, we're going to take all these rows again, scoop them up together, and put it into different columns again. So we're going to denormalize it again in the next step. So that's what happens. That's what happens here. So this is a denormalizing step. And if we take the preview out of this one, sorry? Oh, okay, I have to stop there. Okay. So we have this. We had the 2 rows in the previous step, one for the deleted scenes and one for behind the scenes. And by the time we pass this step, these 2 have been put together again, but in a way that we have a flag for the deleted scenes and a flag for behind the scenes. So we denormalize the data again, but 2 separate columns. A similar thing is done here for the categories. For one movie, we can have multiple categories. In this particular case, categories were stored in a different table. So we don't have to do the normalization step because it's not stored in a list. We just can use the already normalized data and denormalize it again to create a column for each separate category. Okay. So finally, we need to do a little bit of massaging, because we in this denormalization step we can actually make a flag for yes, this film has a deleted scene, or yes, this film is in a particular category, but we still have to fill out the empty fields and the empty flags and tell them that they're no. So every movie that doesn't have any deleted scenes will have an empty column there, and in this step we just fill in the blanks and make sure that there's a nice no flag. And finally, when we end up here in the final step, when we load our film dimension. Okay. I guess I have to stop it again. So finally here we end up with a whole bunch of flags for the special features. So it has behind the scene, has commentaries, has deleted scenes, and so forth. And we also end up with a lot of flags for each different category. So they're all denormalized. And nice to know that for every film we put in there, we're getting exactly 1 film out of there, but with transformation has happened, because the film that went in there isn't, well, it's the same film still, but it's adorned with a lot more attributes as we go along this transformation. Okay. So typical transformation, we load up the different dimensions, and finally we load the fact table. And this is by far once we loaded all these dimension tables, the loading of the fact table is pretty easy, because the only thing we have to do is we have to take the rental table out of our operational system, and we have to just get all the data out of there, or at least all the data since we loaded it last time. And then we just have to look up the key in our dimension tables in order to put it into our fact table, so that for each row that ends up in the fact table, we have the fact itself, the metric itself, along with every dimension along which we can cut up these facts. So that's what we see here. We load all the rentals from our operational system, and we just look up the date key, we look up the time key, and in this case we're all looking it up in the data warehouse itself. Because we already loaded all these dimensions, we can now look up the keys in our data warehouse, so we can finally store them in our fact table. So look up date dimension, look up time dimension, look up the store dimension, look up the film dimension, customer dimension, and so on and so forth. And finally we end up with the actual rental fact, which we can actually report stuff on. So, okay. So, is there anybody who has any questions about this process of loading data, or perhaps about star schemas?
Yeah, normally what I've seen, many databases actually already do this normalization if it is a good database. They're already using this Boolean flags to identify certain features.
Right.
But this is just a reverse if. Of course, if they haven't done it, then
right.
you are able to do it.
Okay, the question is, most operational systems or well-designed databases won't have a list of special features in there, so they would already have these flags. That's a good point, and it's a good point because in reality, database systems are not designed well. That's one of the things you run into constantly. ETL is much about fixing what was wrong in the first place. The category thing is another case, because in an operational system, the business logic just dictates that there is a list of categories which is possibly dynamic. Right now, our transformation does not take care of creating new columns if a new category was added, but trust me, that's easy. We just didn't show it because it would be showing too much and make it too hard to, but that's easy.
You say, if I understand it correctly, this product is for, let's say, a guy who was given a task, basically, hey, we want to set up a business intelligence unit to do nice reporting to our management every single week. So the guy without, let's say, computing knowledge, he can easily click,
yes,
and make this happen.
Yes. I think, yeah, to a large extent that's true. I think that, but to be really frank, if you want to do some serious BI stuff, it doesn't hurt to have SQL knowledge. But this tool is going to save you a lot of time, because it's going to be. If you really have to program all this stuff, there's a few cases. I already mentioned them, but it's good to repeat it. First of all, the source data may not be, or often is not, in one and the same source system, but it's in different systems. So if you want to look up data in different systems, and you have to, do this jiggery pokery lookup stuff from different systems, then database alone is not enough. You need some extra tool anyhow to do that. You can program it yourself, but this is going to be a lot easier and a lot faster to do it. So that's one reason. The second reason is that if you would really do SQL, typical SQL queries to do this stuff, and some people do that, then you're going to have this problem of, that's going to be a lot of work. You're going to have to type a lot of fields, you're going to make typos, fields will change, and it's going to be hard to find out and figure out where exactly in your code it's going to be, where you have to fix things. In this case, you have this graphical layout, and if you have to invest some time to give a good proper name to your step and maybe add a note here and there, but it's going to be easier to find out exactly where stuff is happening. And if you run the transformation, and you make some mistake, it's going to tell you exactly where it went wrong. So it's going to be easier to figure out what you have to fix. A third reason why you want to use a tool like this is for performance. If you're going to create all this transformation stuff on your own, by your favorite programming language, then you're going to have to make some kind of design for how you're going to execute your code in time. And the decision you make now for that process, you're going to say, oh, we're going to load this, and then we're going to load that, and then we're going to load that. You're going to end up with a sequential process. You're going to end up with lots of chunks of program, and it's not going to scale, because it's going to take a lot of time to execute all these things sequentially. Cattle is designed intrinsically as a multi-threaded tool, and every step, it's not like when you're doing a transformation, it's not like you first do this step, and then you did this step, and then you this step. All the steps are executing at the same time, in parallel. So it's a stream-based thing. The input rows are being fetched, and they're being thrown into the rest of the system as you go. So it's impossible to say. Some people ask me, so what step is it at now? It's impossible to say, because it's in all steps at the same time, right? And that's something that for large systems will scale, because you have, if you have multiple processors, it's going to scale out over all these processors because it's multi-threaded. And you can actually do things like, if you find some kind of bottleneck in, for example, these lookups can be expensive, because you have to do a database lookup, and it's going to take some time to do that lookup. It's going to have some latency, especially if the database system is on another host. And what you can actually do is you can actually use a cache, so that will internally cache and make the lookups a lot faster. Another thing you can do is you can actually up the copy number. So if you say, I have a lot of processors which are sitting on my machine doing nothing, you just add more. Oh, okay. So I'm just going to say I'm going to make 3 copies of this thing here, and this means that I'll be having three threads busy executing this step. Yeah. Of course, you may need to synchronize some stuff if you're doing this kind of things, but in many cases you can parallelize. In many cases, it will actually up the performance. And there's a few things in Kettle which actually allow you to find. So I can actually, let's do this. Maybe the rentals might. So I just want to run it. So here you can see the transformation running right now. You can see for each different step how many rows it has read and how many rows it has written, and how much time it took. You can see a moving average of the speed, the number of rows per second that went through this step. And if you want to really dig into it and find some bottlenecks, you can use performance graph. If you enable this, we'll run the transformation again. Yeah, it's finished pretty quickly right now because I can maybe. Okay. So now we have logging. Yeah, but okay, it's still too fast to actually tell something about it. But you can, for every step, we can actually see the contour of how many rows it actually processed, and we can look for different aspects. We can look for the read, for the write. We can look for the buffer, the buffer sizes, and this is what I found to be most useful, to see if the buffers get filled up or not. So every step has an input buffer, output buffer, and when those get filled up, that's usually a good candidate to make more threads out of it, because you can have more buffer, and so you're going to have more throughput. And this is something you're going to, first, you just put together your transformation, and then when you find it doesn't perform, because you should always, I guess, transformation like this is going to be ready in 5 minutes, no matter what. And you're going to, move a lot of data with those 5 minutes. And if it's fast enough, you shouldn't bother. But of course, there are people that are using the Kettle for terabytes of data, and in those cases, it's going to be your load window might be a problem. And in those cases, you might want to look at your performance using these tools and actually up the number of threads for a particular step if you find that the buffer is a problem in those cases. And you're gonna gain performance with that, or at least if your machine has enough processors, you can actually scale that way to increase your performance or your throughput. And if that isn't enough, you can actually cluster Kettle. You can actually, but that's something more Matt can tell you about. So you can actually take a lot of cheap machines and have them run the transformation in a distributed fashion. So this would actually allow you to, well, to basically linearly scale your transformation, because you just throw more machines at it and it will just increase your throughput. Okay. Okay, is there anybody else who has a, yes? Sorry, when the data?
Yeah, I recently
Yes, we can make a data vault.
Oh, data vault, yes. Yeah, right. Basically, it doesn't really matter, because data is the Kettle is a tool which is, in a sense, it was designed for data warehouses. It has some functionality which is especially good for like slowly changing dimensions and that kind of stuff. It does a lot of that kind of work, but it's basically so generic that people are actually using it for plain schema migrations. And for data vault, I mean, I don't think there are specific steps that are actually take care. Yeah.
We're thinking about. I recently did a workshop with a customer where we created things like data vault. We also looked into like organizational memory architectures and you know, for Sarbanes-Oxley compliance and stuff like that. There's a lot of checks if that routing of data that needs to be done, but it's probably going to be difficult if you need to. But I think it was okay. It went really well actually. People were excited about possibilities. But actually, it's not a linear path. It's more like if this happens, send the data over there, and then split it up again, and it's like a whole set of logics that we do now by default in our slowly changing dimension. It's very similar to what you know, Datafold and OMA does. Like you know, to make those processes easy for Datafold as well, we're actually working together with EKW and here in Holland to make a couple of dedicated steps for those as well, to make it easier, more abstract and easy to use.
Yeah.
But there's nothing that prevents you from creating that.
Yeah.
As long as you don't expect to be able to report on a data vault structure, then it's fine. It's not intended to do that. So typically what people do is they extract star schemas from the data vault. Then you're fine.
Two-step.
So for those things, like create the data vault and create the star schemas afterwards, which is very easy if you have a data vault afterwards. You know, if you have a data vault, you already have technical keys and everything. So extracting the data
marts. Yeah.
It's very easy actually.
Yeah. Yeah.
Both those processes you can use.
Yeah. So you can use it. Basically, the target structure or the source structure is not extremely important, because there's so many steps in there that you can always build it yourself. And because you can reuse steps, if you're really clever about it, you can maybe reuse some logic and put it in different transformations. So there's nothing that prevents you from using Kettle and reap the benefits of the multi-threaded stuff, because that's basically one of the things I think is particularly strong about Kettle, that you can scale it easily. Yeah, it's all GPL. You can just to give you an idea of the capabilities when you create a new, when you extract data from some kind of system, the database connections you can create is well, it's JDBC based, right? It's basically JDBC connectivity. But if you look at the amount of databases you can actually access with Kettle, it's well, it's not an endless list, but it's pretty big list. There's a lot of, I mean, I think it's pretty hard to find a database that doesn't, that doesn't fit in here. And if it does, if you have a JDBC driver, you can always use a generic JDBC connection to actually pull data out of there. And
LucidDB is not in there, and a couple of others.
but it's coming, right?
These are very obscure databases that some of you have. Like that MySQL fork.
Drizzle, yeah.
Drizzle. Although I bet you could use JDBC stuff from MySQL.
Yeah, you can still, yeah. Yeah. Yeah.
Yeah, so they go directly to the database. They don't use any file for You can also use ODBC or OCI for Oracle, for example, or Jitney connections. So those passwords are yeah, all fine.
Well, what do you mean exactly with native? Because
JDBC actually there's a connection between our software kettle and the database.
right,
So it's a native directive connection.
right.
So other connections like ODBC usually pass a client.
Right. No, but I mean,
Oracle
but
client or
those are by GDBC.
yes, yes. But for example, MySQL JDBC driver is a native driver because it's the Java code that's directly talking to protocol. And you probably mean native. It has to be some kind of C library, to yeah. But in the MySQL case, it's a native driver. It's because it's Java, doing the protocol. Right? Yeah. If you really like, you can use ODBC, which wraps around the native C library. But
typically slower.
yeah, it's slower. Yeah.
It doesn't really matter that much. Usually you can read as fast as the database can so the rest of the line.
Yeah, that's it. Database performance is usually more of a problem than the driver.
But in cases where you have a local MySQL and everything is in cache and memory, you can typically read 150,000 lines per second or something like that. It's usually fast enough for many purposes. It's not the input side in that case that is the problem, but you're going to land that data somewhere in the table, and then I think these tools max out at 10, 20,000 rows a second sometimes. If you do bulk loading with Postgres, I had 40,000 rows a second, but never 100,000 rows per second. Because that's the writing is more expensive for the database. It has to do all kinds of organizational stuff in the background.
So there's a question over there?
Just connect by a MySQL socket?
No. The MySQL JDBC driver does not use socket, always uses TCP/IP. Yeah. Well, actually, the people that are into Drizzle right now, they're moving away from sockets. They're not using Unix sockets anymore. They're doing everything TCP/IP. I know that in some cases socket can be faster, but it's typically it's fast enough. The driver is fast enough. It's more like Matt told you, the writing stuff is usually the bottleneck, if anything. So. And another nice thing about Kettle is that you have so many steps for for non-database input. So if you have an Access database or that's I guess a database too, but CSV or Excel. Well, Excel is huge. Organizations are keeping all kinds of little reports or data or reporting in Excel, and if you have to pull that stuff out of there, then you can use Kettle for that. Fixed file input. XML. Some cases you have people that especially when you get data from another organization, they like to use XML because it's I don't know why, but they use, and you can actually use you have I think you used to have two steps for XML, the streaming one and the still there, okay. LDAP.
The data from XML is using the latest XPath technology. We can use any XML format with that step.
Oh yeah, I see it here. You have get data from XML and you have the XML input.
It also is capable of reading, parsing XML that comes from the database or database field services that you stream the data through.
Okay.
Pretty cool actually.
Yeah, so you have, I guess that would be the lookup step. You have this.
We have also stuff like XML joins, and all kinds of weird stuff for XML.
Yeah, so can you, for example, use the HTTP client step to get a web page and actually use the XML steps to to extract data from there? And
Data from an HTTP page from a website, get that XML back, and then you parse for multiple websites. Yeah. So more and more people are using this not just to do classical data warehousing, but also enterprise, application integration, message passing, all that sort of stuff. It just gets wider and wider.
I think the best thing to do is just download it. It's like a 50 meg zip, something like that. Just unzip it and it just works. No installation, no repository setups. If you really want to, you can use a database repository to store your stuff, but it's typically very easy to set it up because it's just just say yes and it will actually create a repository for you. But it's really easy to get started with Kettle. A lot of examples in there in the samples directory beneath your Kettle.
If you go to the welcome page, so we have the get started page, link to on the. There's actually a browser inside the and we made flash demos for you to see how you can edit steps, how you can create and drop them. So usually if you go to the get started page, take you 5 minutes, something 10 minutes tops, you know how it works and you know how to get started. Usability for us is very high on the agenda. Always like continue on. So all the SQL that you need for target tables and stuff like that can be also generated by Kettle. This is one demonstration. You can edit that stuff. It's too big to just give a half-an-hour overview. It's better that you just try it yourself. And on the welcome page you will also find links to our forums, our bug trackers, our community, the rest of the documentation. All out of our wiki, all public there. Alright, thank you very much.